Hello dear friends. So today we are going to start from the fundamentals of organic reaction mechanism. So any organic reaction generally has a substrate which reacts with a reagent to give the product as well as some byproducts. Let us take an example. CH3Br when reacts with water, that is it undergoes hydrolysis to give methyl alcohol plus HBr. That is, here the substrate is the methyl bromide which reacts with the reagent H2O to give the desired product methyl alcohol with the byproducts HBr. So now let's see what is this substrate called. The substrate is the main organic compound which takes part in a chemical reaction. It is the species on which the attacking reagent attacks. This substrate may be broadly classified into two types generally. Those are electrophilic substrate and the other one is the nucleophilic substrate. So what does the word electrophilic means? Electrophilic means the species, that is the substrate, is deficient of electrons, and nucleophilic means electron rich, and this is electron deficient. In reaction medium, examples of electrophilic substances are, for example, any alkyl halides, any aldehydes, any ketones, etc. On the other hand, nucleophilic substrates are those which are electron rich, that is, they have an electron rich center. For example, benzene in certain reactions behave as a nucleophilic substrate. Apart from these, alkenes as well as alkynes behaves as nucleophilic substrates. Now we will move to learn about reagents. So, what is a reagent? A reagent is a chemical species which attacks the substrate to form the products, right? So, reagents on the basis of their nature are again broadly classified into following categories. For example, nucleophiles, B, electrophiles. These are the general two broad categories of reagent. So what are nucleophiles? Nucleophiles are electron-rich reagents, whereas electrophiles are electron-deficient reagents. Now, these nucleophiles can again be classified into certain categories. Number one is the charged nucleophile. Example of charged nucleophile is OH negative, OET negative, NH2 negative, SH negative, etc. These are the examples of charged nucleophiles. Apart from these, another type of nucleophiles are there which are called neutral nucleophiles. So examples of neutral nucleophiles are R3N, RNH2, H2O, that is those which have complete octet as well as a lone pair of electrons. Those behaves as neutral nucleophiles. Another type of nucleophiles is there which is called ambidentate nucleophiles. So what are these ambidentate nucleophiles are called? Ambidentate nucleophile means those nucleophiles which have two centers to attack to the substrate. Example is the greatest example, cyanide, SCN negative, NO2 negative, etc. If we see the structure, we will find that the cyanide might attack from this end as well as this cyanide can also attack from this end. That is, this is also an attacking end as well as carbon is an attacking end. So this type of special nucleophiles are called ambidentate nucleophiles. For example, another one is this one, SCN. It can attack from sulfur end as well as it can attack from nitrogen end also. So these are the special nucleophiles where both the ends can attack to the reagents. Right? Now we will learn about electrophiles. So, what is the electrophile? Electrophile is a chemical species which has electron deficit center. That is, they are electron deficit species. Electrophiles can again broadly be classified as charged as well as neutral. Right? Examples of charged electrophiles are H+, R+, NO2+, SO3H+, etc. These are positively charged species. So these are charged electrophiles. Generally, Lewis acids, example BF3, AlCl3, are neutral electrophiles. Some other examples of neutral electrophiles are CS2, zinc chloride, etc. Apart from charged and neutral electrophiles, some other species are also there which behaves as electrophiles. Those are free radicals. So free radicals can also behave as electrophiles. Example, Cl dot, CH3 dot, etc. Carbenes can also react as electrophiles. When we move into the deeper section of organic reaction mechanisms, that when we will see the mechanism pathway, then we will understand better that how this behaves as electrophiles. So what are the free radicals? These free radicals are nothing but those species which have unsatisfied valencies. Okay. So let's move to the first example again. From this example, we can easily understand that here some bond cleavage takes place with the formation of new bond. So bond breaking and bond cleavage is the basic fundamental of any organic reaction mechanism. So let's now move towards this bond cleavage. So in organic chemistry, bond cleavage is broadly classified into two types. One is homolytic fission, another is called heterolytic fission, right? So what is homolytic fission? Whenever a bond fission takes place resulting in the equal distribution of electrons between the two atoms, then it is called homolytic fission. So homolytic fission takes place when the electronegativity difference between the two participating atoms is almost negligible, tends to 0. In that case, homolytic fission takes place. That is, we can say homolytic fission gives rise to the formation of free radicals. These are the examples of free radicals. On the other hand, if we see heterolytic fission, we will find that heterolytic fission gives rise to cations and anions. When the electronegativity of A is more than that of when the electronegativity of B is more than that of A, then this bonding pair of electrons will be shifted towards B. In that case, cation A is formed and anion B is formed. However, if the opposite thing happens, that if A is more electronegative than B, then anion A is formed along with the formation of cation B. For example, if we see this carbon-chlorine bond cleavage, we will find the formation of a carbocation along with the formation of chloride ion. That is, we can say heterolytic fission leads to the formation of carbocation, that is carbon bearing positive charge, as well as carbanion, that is carbon bearing negative charge. So from here, what we can conclude? We can conclude that in organic reaction mechanism, bond cleavage, which is the basic fundamental for any chemical species to undergo a reaction, is generally of two types. One is homolytic fission, another is heterolytic fission. Homolytic means the equal distribution of the covalently bonded electrons between the two participating atoms to generate the free radicals. Whereas in heterolytic fission, the difference of electronegativity of the two bonded atoms plays the major role, which ultimately generates carbocations as well as carbanions. So today up to this, in the next session we will start from the formation of carbocations, carbanions, and we will study the various electronic effects which plays a vital role in organic molecules to initiate them to participate in organic reactions. Thank you.